We will now look at the first few lines of a sequential implementation of preflow push in Rust. And during level 5, you will get an incomplete version and then make that complete. And when this sequential program works, you should parallelize it. You are free to change essentially everything. So you view this as a hint. First, to represent an object, we use struct, and then here are examples how to use the node and the edges. And the first attribute, I, is not needed for the algorithm, but can be useful for printing debugging information to see which node is doing what. And then the excess preflow and the height are signed integers. Obviously, the height can never be negative, but I use that anyway. Okay, and the edge, here is something interesting, namely, well, first we have the flow and the capacity, and two nodes, and the nodes are not pointers. Instead, they are integers being indices into an array of nodes corresponding to, I mean, this value here. But this value here, the I is not used, it's just the index into the array of nodes. And why? Well, if we store pointers, the program will be more complicated due to the ownership rows. So it's much simpler if we use integers instead. Okay? And to create a node, we have the new function and the parameter. I use two characters for the parameter. When I want to initialize I use that I, and the excess preflow and the height. Okay, and similarly for the edge. So I just we just initialize the attributes with the colon in a comma separated list. Okay, so let's look at main. The first thing that we do is to read the number of nodes and edges, and that is done with read exclamation. Okay, since we use the same input files as in the algorithms course, and there is additional input in, for the lab that is not used in this lab, we have to read these two C and P parameters and forget them. And to do that, we call them or give them the name underscore. Otherwise, and following C and P, otherwise the compiler, Rust compiler, will complain that we read something and don't use it. Okay, and then I should say we have an array of nodes and an array of edges and an array of adjacency lists. So to create the adjacency list, it is a vector of linked lists of unsigned integers. And then we also say the capacity of this vector. Okay, and then we have a queue for nodes with excess preflow greater than 0. Okay. Well, we can initialize a variable using s without describing the type. We can print this, and then we can create the different nodes, and we put the nodes in this vector using the construct that we saw with atomic reference counters and mutex in the last slide. And we put empty lists in the adjacency, I mean the vector of adjacency lists. Okay, then we read the graph, and well, we read a U, a V, and a capacity, and create an edge, and put this I in this in the two different adjacency lists, and then put the edge using the same construct with the atomic reference counter in the vector with edges. Okay, so that's a start. And then, okay, I should say one more thing, namely that when we have an if statement, you will get the complaint if you use parentheses like this. So that's the reason why I haven't any. Yeah, well, it's a warning only. Okay, and to iterate through such a list as in the adjacency list, we can use like this. Let well, this variable, and go through it like this. Okay, so that's enough.